This is the very minimal example of a smart contract. It has a single function. When we call this function from outside the blockchain, it returns this string. But let's build something more useful. Let's build a basic example of a smart contract that stores a single value and also can read it back. It will have two functions, one to write and another to read data from the blockchain. So, nothing new here, it is like any Lua program. Now let's define the variable, a special kind called state variable because its value is stored on the blockchain. We put this variable inside of a block called state.var. You can choose its name and its type. In this case it will be of type value, to store a single value. Now let's implement the functions. Easy. This is the syntax to write to a state variable. And this is the syntax to read from one. It is almost done. To transform this code into a functional smart contract, we just need 2 additional lines of code. As smart contracts can have public and private functions, we need to inform which functions are public, those that can be called from the outside world. We do this at the end with a line like this. And we add the names of the functions that should be exported. In this case, we will export the 2 functions. Okay, that was easy. The next thing may not be so obvious to you. This code is ready to be deployed to the blockchain, but it has a security problem. There is no control of who can call these functions. This means that any person could call the right function and overwrite your data. Well, in fact, they will still be able to call the function, but we will add a line at the beginning of it to check if the user calling it is authorized. We can do this by using an assertion. But how to know who is calling this function? I left this comment here below showing the modules that are available for use. It turns out that in the system module there is a function that returns the address of the caller, system.getSender. And we can compare this address with the address of the creator of this smart contract, using the getCreator function. Now if this function is called by someone that is not you, the contract will issue an error message. And voila, your smart contract is ready to be deployed to the blockchain. Wasn't it easy? In the next videos I will show you how to deploy a smart contract to the blockchain, how to interface with it from different programming languages, and many features you can use on your smart contract. Stay tuned.